we are more than 50 Flutter developers. As a developer of a consulting company, it happened to me to jump between these various projects frequently in the same week or even in the same day, at some point causing this struggle. Because every project has its own peculiarities, UI and UX, features, and also, of course, backends and API integration. Today, I'm here to tell you I faced this challenge to avoid this struggle, defining a standard for the API integration across our Flutter projects. And a little spoiler about it, I used the DIO library. Hi, and welcome everybody to From Zero to Network Manager Hero. This will be a more static talk because I don't have the clicker. Previously, I tried to use it, but I have an issue with the Mac, so sorry, I will be there. I'm Marco Facco, a Flutter expert digital engineer with Android background at Digital Experience for Entity Data Italy. And today I'm here to tell you about our journey, of course, with Flutter, and of a particular challenge I faced in these last years. So our journey started with the very first stable release of Flutter in 2018. We started using Flutter with some internal experimentation, and then we started proposing it as a mobile solution, as a solution for the mobile development to few of our clients. And in the following years, it started to convince us more and more until we adopted as the main framework for the mobile cross-platform development, replacing Xamarin. Thank you, Flutter. Then, with the release of Flutter 2, we started using Flutter also for the web development, and also proposing it to few of our clients again as a solution for the web alongside the mobile. Today, we have more than 20 active projects for pretty much all the supported platform by Flutter. And we are more than 50 Flutter developers. And as a developer of a consulting company, it happened to me to jump between these various projects frequently in the same week or even in the same day, at some point causing this struggle. Because every project has its own peculiarities, UI and UX, features, and also, of course, backends and API integration. And today I'm here to tell you I challenge these, I faced this challenge to avoid this struggle, defining a standard for the API integration across our Flutter projects. And a little spoiler about it, I used the DIO library. This is the agenda of the talk, and as the title say, let's start from zero. And the zero is the easiest way to visualize an API interaction that for me is a Google search. When you search something on Google, as you may already know for sure, the browser makes an API call for us, and specifically, it makes a request to the Google server. With the help of the inspector, we can identify the fundamental properties of a request, like the URL, the HTTP method, and other stuff like headers or query parameters. If we try to remap all these properties, all these concepts inside a Dart class, we can obtain the core class of this approach, that is a request-driven approach. That is the myRequest abstract class. This class contains, again, the fundamental properties of a request, like base URL and endpoint, that are composed together inside the complete URL getter. The HTTP method, where HTTP is an enum defined by me that enumerates all the method provided by the HTTP standard, so the get, post, put, etc. The headers of the request that by default has application JSON value for the content type header and the accept header, because they are the most common case for us, and the getter for the content type header that I will use later. The optional parameters for the request, like the map string dynamic for the query parameters, that by default is null, and an nullable object for the body. Nullable because, of course, there are some cases, like for the get request, where the body is null, and the object because the body can assume different form, like a plain string, or a list of bytes, or a JSON object, or even a list of JSON object. And the last, but not the least, the response type. Response type is an enum provided by the DIO library that allow us to define the expected format of the response body, that again, by default is the JSON, because it's the most common use case for us. But you can also define, for example, a plain string if you want to receive, or not if you want, if the API return you a string, or even bytes, if you are trying to, for example, downloading a file. And back to the Google search request, if we use this approach to rewrite it, we obtain a Google search request class that extends, of course, the myRequest class, define the google.com as base URL, the search endpoint, the get method, and requires in input a search text, a string parameter, that it is used to value the Q parameter. Okay, I defined the core of this approach, and now we can talk about DIO. First of all, why DIO? Why have I chosen DIO? Because it is a reliable and well-maintained package, and because allow me to implement easily features like multipart request, request cancellation, upload and download of files, and transformers and interceptors. So, sorry Vadim, I'm using an external package. Is an external dependency, so let's add it to the project with the dart pub add command. And finally, we can create the first instance of DIO with its primary constructor that allow you to define also a parameter that is of type base options. This class, again, is provided by the DIO library and allow you to define common properties that will be in common to every request sent by this specific DIO instance. For example, if you want to have the same headers for all the requests, you will define it inside the base options, and all the requests will have them. But this is a request-driven approach, and I don't want to use them. Instead, I want to define all the properties of an API inside its request, its related myRequest specialization class. And that's why I'm not going to use them. In any case, I'm not going to use the DIO client directly, but I'm going to wrap it inside an helper class that is the myHTTP client abstract class. I know I don't have so much fantasy in naming class, so sorry. This class is delegated to set up the DIO client. And to set up the DIO client, you can provide base options. Yes, previously I said I don't want to use them, but at the same time, I don't want to deny the ability to use them because they are very useful in some use case. A list of interceptors, where interceptor is a utility class that I will show you later. And two functions, the create HTTP client and the validate certificate. These two functions are useful in a specific case that is implements the SSL pinning, because with the create HTTP client, you can instance your security context, load inside the certificates, and do the chain validation. While with the validate certificate function, you can validate the leaf of the chain for the SSL pinning. Those two particular functions are not supported on the web platform because the internal HTTP client adapter of the DIO library has a different typing, that is a browser client adapter, and it doesn't support it. Okay. Inside my HTTP client also, I'm going to define a function that will be useful to send effectively the request, and it accepts as an input parameter an object of type myRequest that is used to set up all the useful data, like the options, useful to send the request through the DIO client. Options is a class very similar to the base options class that you have seen before. The DIO client internally compose those two objects because they list pretty much the same parameters. And the options defined inside the parameters defined inside the options will overwrite the base options parameters. So taking the example I did before, if you want to define or overwrite the specific headers for this particular request, you can define the headers inside the options, and then they going to override the base options parameters. The DIO client request is a generic method that allow you to use whatever HTTP method you want. Actually, the DIO client exposes a function for every HTTP method, like a .get or .post. But I'm okay to use a generic one and specify the method of the request inside the myRequest class and inside the options class. The return type, as you can see, is a future response, and as you may expect by the name, it contains all the information about the data sent back by the server. And now we can talk about the response management. But first, I switch to another example because, yes, the Google search is a pretty easy example to expose, but it returns an HTML page that is not canonical for a mobile application. So I switch to another free API that returns JSON object, and this JSON object represents a random emoji. And all I have to do is define this class, and the nice thing here is that this API is integrated in just 9 lines of code. That's very cool if you think. So if you debug the response of this API, you will have something like that. This response contains a field named data that is aka the body of the response, that in this case contains a map string dynamic that represents this JSON object. And all other data like the request options. So inside the response, you will have also the parameter used to invoke the API, and other stuff like status code and status message to validate the result of the API response for manage a successful response or error, and the headers, of course. Previously, I said that this API returns JSON object, but we have inside data a map string dynamic. Why? Well, it's because when you specify the response type as JSON, the DIO client do an internal check for us when it receives a response. And if the content type content type header of the response is equals to application JSON, so you have a response type JSON, content type header of the response, application JSON, it JSON decode the response body for us, and that's why we have a map string dynamic. In case of a list of JSON object, of course, you will have a list of map. This JSON decode is run into a transformer, and this transformer is very smart because if the response body is too heavy, like more than 50 kilobytes, it runs the JSON decode in another isolate to avoid heavy computation on the UI thread. Okay, I don't want to anyway manage map string dynamic or list of map for safe and soundness of my code. So I'm going to define a data transfer object class to remap the map inside an object with the from JSON constructor. I know, boring stuff. You can use freezed, .mappable, whatever you want. I used quicktype.com. I didn't write by hand. And we can use this from JSON factory constructor to use the mutability of the response data. I didn't say before, the data field of the response is a dynamic and mutable field. Why? Because the response body could be null, or a plain string, or a list of bytes, or a JSON object, or a list of JSON object. So that's why. And exploiting the mutability of the data field, we can change its value, and replace it with the result of the from JSON constructor. That's very cool, but is very specific to this API only. And I don't want, again, a lot of specific function for every API. But I'm OK to just have a generic one that I can reuse again and again. So following again the request driven approach, I'm going to define inside the myRequest abstract class a function that is the decoder of the response body that accepts in input a dynamic object because the response data is dynamic, and return a dynamic object again because it depends on the API if you want to use directly the response body or you want to do some changes. Is up to you. And the get random emoji request change accordingly, defining the emoji DTO from JSON factory constructor as the decoder function. The request function of the myHTTP client change because now I'm going to introduce a generic T that allow who is invoking this method, who is using the myHTTP client to define which type is expecting inside the response. That must be the same return type of the decoder defined inside the request. At line 11 and 12, we are going to use the request decoder, decoding the response data in an object of our domain or whatever you want, and the casting as T, because again, the decoder returns a dynamic object. And then I'm going to recreate from scratch the response, defining the T generic for the response. And I'm not going to return directly the response, changing the value of the data, because the compiler will send me an error, because I'm trying to return a response of dynamic instead of a response of T. Following the transformer approach, this code could be enhanced, moving the decoder execution inside another isolate to avoid, again, heavy computation on the UI thread. And now we have done. You can easily implement your MyHTTP client and retrieve whatever you want of emoji. Enjoy. I'm joking, not so fast, because job's not finished, because error occurs, and we have to handle them. Well, when the IO client is running, the request method is running, and something bad occurs, the DIO library throws us a DioException. This class contains all the useful data that allow us to debug and handle the error, like the request options used to invoke the API, the response of the API if it is available, because why is null? Because you could have a no connection error or a timeout error, and in those cases, there wouldn't be any response, of course. The type of the exception, like timeouts or bad certificate, for example. The error itself, the stock trace, of course, and a short description provided by the DIO library. There are different types of DIO exception, like timeouts, bad certificate if the SSL pinning fails, or bad response if the status code of the response is not in the default range that is 200, from 200 to 299. And that range could be defined by you using the validate status callback and providing it to the base options class or option class, or because the request has been cancelled, or for unknown reason, that's the fallback for the DIO exception type. A fun fact about the DIO library that Italian developers already know and maybe already get where I want to go, is that the DIO word in Italian is God. And the first time I received a DIO exception, and actually the first name of DIO exception was DIO error, I felt like this. But anyway, as you expect, I'm going to wrap the MyHTTP client request execution, the code, with a try catch, catching specifically for DIO exception, and other error. And I'm going to change a little again the request method, because now I'm going to introduce 3 different classes that come from the fpdart package that are header, left, and right. Okay. Why? Because I don't want to throw again exceptions, but I want instead to return a single object, in this case the header, that can contains or a right successful response or a left an error. And the header is like a Schrödinger box. You know what it is inside only when you unfold it. And to catch specifically every type of exception I'm going to manage, I defined 3 different methods: the manage DIO exception, the manage exception, and the manage error. That, as you can see, are abstract methods and return a E object, where E is a generic that should be provided by who is implementing the MyHTTP client, and stands for the error model that the handling method should return. And this model must be defined by the implementer of the MyHTTP client, so by you. Because I don't want to define a standard error model that maybe will be remapped because it not fit your your code or your domain. And also change the myHttp client class annotation, because now you have to define also the error model and the request class that must extend the myRequest that the HTTP client will manage. Okay. Oh, well, sorry, I forgot one thing. So as you can see here, the request method return a very long typing, because it's a feature of either of E and response of T that is very long and very difficult to say. So I defined a type def to simplify it with a future either response of E and T, much better. And to summarize all, you can just implement your myHttp client, defining the myError class and your myRequest class. In this case, I didn't, but you can if you want. And defining the management for all the exception catching before. In this snippet, there is an example of how I would like to manage a different type of DioException type, but you can do whatever you want. And okay, be with me because the end is near. Don't sleep, please. And now I can talk you about the nice-to-have feature that I mentioned at the beginning, starting from multipart request that allow you to manage upload of data and files in an optimal way. So to manage them, I created a specialization of the myRequest class, the myMultipart request, that has little changes, like the default content type header, that of course is not anymore application JSON, but now is multipart form data. And the other change is how the body of the request is generated, because now I'm not going to use the body getter, as I showed you before, but I'm going to define an abstract method, the generate form data, that return a future of form data. Form data is a class provided again by the DIO library and allow you to manage the upload in an optimal way again, because it fragments all the data and files and allow the DIO library to send them fragment by fragment through a stream to the server. The request method change again, because now I have to introduce type check on the request, and if the request type is my multipart request, we are going to value the request body with the result of the generate form data function. Otherwise, the classic request body. The second feature is the download of file. Again, I'm defining a specialization of the myRequest class, the myDownload request. And this class has more changes because I'm introducing a progress callback that allow to receive updates while the download is running. And it provides you the bytes already downloaded and the total length of the file you are downloading. That is read by the DIO library using the content length header key, and a flag to define if you want to delete the file if the API is not successful. And the list is a generate file path function that is an abstract method. The signature of this method is defined by the DIO library. I didn't define it. You will receive in input the headers of the response, and you should return a path. This path is where you want to persist the file inside the file system of the device. But why am I talking about persist or delete a file? Well, because I'm not going to use the request method of the DIO client, but now I'm going to use the download method of the DIO client that not only download the file for us, but also persist it at the file we are going to provide using the request generate file path. As you can see from the snippet, this method is not directly inside the MyHTTP client, but I just put it inside a mixin, the myDownload client mixin. And why? For mainly two reasons. Because the first one, the download method return a response body and not anymore a response of something. And the second reason is that on the web, the download method of the IO client is not supported because there isn't a file system. Is like a plug-and-play approach. So if you need it, you can add it. You can extend the implementation of the MyHTTP client with this mixin, and you can download all the files you want. Otherwise, if you don't want to leave the persist of the file to the IO client, you can also use a classic myRequest receiving the list of bytes and then manage the persist of the file by your own. Okay, now let's talk about interceptor. What is an interceptor? It's a utility class that allow you to interact with the lifecycle of the API, allowing you to change the request before it is sent to the server, and also change the response before it is returned by the IO client. And there is a specific thing I want to highlight about interceptor, that is the communication between the my HTTP client, or in any case by the IO client to the interceptor, between those two classes. That is available using the extra map, that is a parameter provided by the options and base options class. And you can use it for this purpose. So I'm going to add a getter for the extra map inside the myRequest class that by default is null. And the cool thing about extra is that the extra are not sent effectively to the server. So if you try to debug from the log of the server of your backend the request is that is managing, you wouldn't see them. And they are very useful in some use cases, like headers. If you want to add headers to your request based on a particular flag, for example, the authorized flag, that allow me to choose if the request should have the authorization header or not, because it is a public API or an authorized API. And in this way, you can just do a request granularity choice, or even to mock the responses for your request. In this case, I'm using another flag. And if the flag is true, I'm going to replace the base URL of the request and send the request to a mock server. In any case, if you don't have a mock server, you can also mock the responses using static assets. In fact, if you need it, you can override the request method of the MyHTTP client, checking if the request is mocked with a flag or a global configuration, and defining the strategy of how load the correct mock file based on the request. You can load the file from the root bundle, JSON decoded or decoded, whatever you need, request decoding and return the response with the decoded data. And now we have done for real, no joke. Final words about it. Is it worth? Well, yes, I wouldn't be here otherwise. You are now a network manager hero, and not only a Flutter hero. Congratulations. I have defined a customizable standard for API integration that allow both request granularity, so request configuration, and also global configuration. It is a reliable code because it is used in different projects of ours. And the cool thing is that it can be templated. Actually, we have a template, a brick, a Mason brick, that we use to generate the base project when we have to start a Flutter project from zero, allowing you naming convention and other stuff. It's not all my, don't worry. The initial struggle is, of course, reduced from an API integration point of view. And this is a hidden point, but it encourages also the collaboration between colleagues, because this is like open source code for our area. So everyone could fix it, improve it, request change, open a bug, and all can help to maintain it. And thank you. If you have any question, if you want to reach me, you can use the tag you see on the screen, or you can reach me at the stand of entity data. And if you are brave enough or mad enough, it's up to you. You can scan the QR code and work with me.